Welcome back. Yesterday, we reviewed while and do while. We're reviewing how to create loops. So, loops, the two options, they are basically equivalent. You can use one or the other. For the while, a condition here. And the group of instructions that you want to repeat inside of the curly brackets. For the do while, the same idea, but the condition go at the end. And yesterday we reviewed the difference between the condition first or the condition last. So you execute the instructions 0 or more times or 1 or more times. Now, something that we reviewed yesterday, and hopefully you notice after you run the examples, is usually what we need is a condition that somehow is related with a variable, because we need to make the conditions true and false, true for the instructions to run and false to stop. And the only way to do that is using variables, because we can change the value of the variables, and then changing the value is going to change the result of the condition. So it's very, very common that you're going to have variables involved in the conditions. Now, the conditions can use relational operators, logic operators, whatever. Yesterday, we reviewed very, very simple examples of conditions, just like lower than 10, for instance. So you control the variable, and basically you are going to make that variable to be lower or in some point equal or greater than 10, and then the condition is going to stop. If you remember, if we're going to use a variable, we need to create a variable. So something that we did yesterday in the examples is, well, if we're going to work with this variable, whatever, we need to create a variable. And that means we need to define the variable, to put a type to the variable. So it doesn't matter if you use while or do while. Before that instruction, for sure, you're going to have this definition of the variable that you're going to use in the condition. Moreover, because you want to change the value for the variable in order to stop the loop. Something that we did yesterday is one of the instructions that you have inside of the body, right, is this instruction that change the value for the variable. So usually that involves an assignation, and maybe this. It could be adding something, 1, or subtracting something, 1, 2, 3, 4. Some kind of action that increase or decrease the value of the variable, change the value of the variable, and then when the loop go back here or here, you're going to change the condition, and that condition maybe is still true or maybe it's going to change to false. So something that I want you to notice in these examples is it doesn't matter if you use while or do while, but there are 3 elements that you are always using for the loop. Always, you need a variable, at least one. Always, you need a condition, because that is going to stop the loop. And always, in some point, you need to change the value for the variable. And yesterday we reviewed examples in which you change the value first and then you do your instructions, or the opposite. It doesn't matter, but those 3 things happen in both cases, with the while or with the do while. And obviously, here and here or below, you can put the instructions that you want to execute several times, like the print that we used yesterday. So this is kind of the structure for the two statements that we reviewed yesterday. These three elements are a constant in the grammatical structure for them. Today, something that I want to review today is another statement, another option to do a loop. Again, as in any language, there are several options for telling or stating the same. In this case, we are doing loops. Well, we have several options to create loops. In particular, for Java, we have three options. Yesterday, we talked about it. So we can use a while. Yesterday, we reviewed the while. We can use the do while. Yesterday, we did the example with the do while. Hopefully, you run the examples by yourself in your computer. One option that we need to review today is the keyword for, the for statement. That is going to be the third one. And with that, we're going to conclude the review of the conditional statements and now the loop statements. You should be experts in if else, switch, while, do while, and now we're going to review for. And tomorrow, we need to put all of them together in one program. Because so far what we're doing is one program per statement. So we're doing something that uses one of the things. Hopefully tomorrow we can do a big program, big quotation marks, and put several of these in the same program, in the same problem, and see what happens. For the for loop, what I want to show you is the grammatical rule. And the grammatical rule, there is a very good reason because I try to make you aware of the three elements in the do and the while. This is the grammatical structure for the for loop. As you can expect, at the beginning, the keyword, now is for. As you can expect, open curly brackets and closing curly brackets, and inside of them, the instructions that you want to repeat. Remember, we're still working with loops. The new thing is, after the for, you open parentheses, closing parentheses. This looks like the same thing that we did with while. The only thing now is, inside of the parentheses, we're going to put together the variable that we need, semicolon, the condition, semicolon, and the increment or change the value of the variable. Remember the three elements that I showed you with the while and the do while. Those three elements, instead of having one above, one in the parentheses, and one inside, this particular statement gives you the opportunity to put those three elements together inside of the parentheses, and they are going to be limited by the semicolon. That's it. Everything else is used similar to the one before. The loop starts here with the for. Continue with doing the initialization as usual. Continue and check the condition. And if the condition is true, go down, run the body, and when you reach the closing curly bracket, go back, but it's not going to go back to the for. It's going to go back here. This is a difference. It's going to go back in the right side. And that means that it's going to execute this instruction, then it's going to check the condition, and if the condition is true, it's going to go down. What? Yeah, you have a for. inside of the parentheses, you have something here. You have the condition here. You have the increment here, parentheses, the curly brackets. Remember, the curly brackets can be in a new line or in the same line. It doesn't matter. What I need you to remember is your program is going down, right? It's going to read the for. After reading the for, it's going to read this instruction. This instruction is going to be read only one time because after reading that instruction, it's going to read this one, that is the condition. Condition true, go down. When you reach this point, return, that is the loop, but do not return to the for. Return here, and it's going to execute whatever you have here for the first time. This instruction is going to be executed after the first time that you run the instructions inside, because again, this is the path, and here you go down. This is the first instruction that you are not reading the program left to right, the full sentence. If you think about it, you're reading half of the sentence, the for, the variable, the condition. And after reading the condition, you go down. You never complete the sentence. You read all the instructions inside of the for loop, execute the instructions, go back, but you go back from the right. And therefore, you're going to run or execute this instruction here. And then you're going to go right to left for the first time. Going right to left is going to move you from here to the condition. And when you read the condition, if the condition is true, go in. You never execute again whatever you have in this point. Never. That is the flow of the program when you put a for loop. So, reviewing examples, just remember this part. For example, well, this is the equivalent of this for loop, but with whiles. You remember, initialization, condition, and increment of or update. Initialization, condition, increment of or update. One simple program, the simple one with the for loops. Yeah, basically you can use for, while, or do while. Any for loop can be replaced with a while. Any while can be replaced with a do while. Any do while can be replaced with a for loop. The three are loops. You can change any of them for any of the others. Sometimes we're going to have one that is better for some circumstances, but in general, anyone can replace the other. The only way, the best way is experience. What happens if you want to run some instruction at least one time? Always at least one time. Do while. What happens if you want to run the instruction 0 times if the condition is false? The while. What happens if you want to run one instruction a particular number of times, 6, 7, 5? You know the number. For loop is going to be your option. We're going to review examples, don't worry. I am going to give you some hints about when to use one or the other. Right now, my goal is that you know how to use any of those three. Later, we can talk about in which time one of them is better than the other. In some cases like that, a for loop could be the option. Usually, when you are using variables and you have a particular number of times that you want to do something, I mean, you know the number, like when I ask you to print the numbers 1 to 10, your option is for loop. That is going to be kind of the most common option when we talk about numbers. Even though you can write those programs with while or do while, the most common option is going to be for. We're going to be using for a lot. But again, let's first learn the three of them because you need to know them. They are going to be in your exam, obviously. But then we can talk about in which circumstances one or the other is better. For now, let's learn how to use the three of them and how to change one to the other. So in this example, really simple one. One class, one method, and only one instruction, and my instruction is a for loop. The result of this program is print the numbers 1 to 6. Why? How did that happen? I need to be sure that we understand the following. Number one, my program begins in the line 5. The first thing that I do in the line 5 is to read 4. When I read 4, I know that I am going to do a loop. The next thing that I do is to read int I equal 1. Notice that this is the first time that we're using a declaration of a variable inside of the parentheses. You cannot do this in the parentheses of the while. You cannot do this in the parentheses of the do while. The only parenthesis in which you can create a variable inside is the parenthesis for the for loop. You can create a variable inside of the for loop. And this is going to be very helpful because instead of having outside one line above or something, the variable that you're going to use for controlling the loop, you create the variable inside of the same loop. So this is encapsulation. This is, you have everything that you need in the same package. And that is going to help you when you read the program that variable, X, Y, Z, I, because you're creating the variable inside of the parentheses of the for loop, you know that that variable is the one that you're controlling the loop. You know that that variable is there for the loop. Again, put the things in the same package. Put things that are related in the same box. That is a good feature of the for loop. So I read the for. Then I read this declaration of the variable I. And I know that that variable is going to have a value 1. Question, that variable is local or global? Local, it's inside of a method. Good. So it's a local variable because it's inside of the method. I don't care that it's inside of the for loop. It's local. Good. So next, I am going to continue reading and I am going to read I lower than 7. I am reading the condition. Condition 1 lower than 7. Because what I need to evaluate is the number. I is 1 lower than 7. Yes, that condition is true. And something that I need you to notice. I did the for, I checked the variable, I checked the condition, and because the condition is true, in that point, I go down. Never, never, never I read the next instruction. I didn't know what is the next instruction. It's like the door open, go down. In that point, because 1 is lower than 7, I am going to print the value of the variable, right? And what I am going to print is this number 1, and you have the number 1 on the screen. So that is very, very important. In the middle of the line, you go down. Now, because I only have one line inside, when I go down after printing the number, I am going to be reading this curly bracket. When I read the curly bracket, this is a loop, I am going to return, right? Like in the while and the do while. The important thing to remember with this instruction, I am going to return in the right side. And what is going to happen? That now reading the right side, what I am going to read is I equal I plus 1. And the program is going to execute that instruction. And now it's going to be, okay, 1 plus 1 is the first thing that I am going to do. The result is going to be 2, and I am going to store the 2 in the variable I. So my box I is going to become the number 2. And then I am going to continue right to left. And again, I am reading the condition. And now the condition is going to be 2 is lower than 7. True. Go down. Never. I am going to read again I equal 1. Never. Because I am going to be returning to the right, running the instruction, checking the condition, and the condition, if true, is going to move me down. So instruction true, down, print I, and it's going to print the number 2. Again, return the instruction I plus 1, 2 plus 1, store that, the 3 in I. So now this variable is 3. I do not have the 1 anymore. I do not have the 2 anymore. My box is a 3. Continue right to left. 3 lower than 7. True. Go down. Print the variable. I am going to print 3. Go back to the right. 3 plus 1, 4. My variable is going to be now 4. 4 lower than 7. Yes. Go down. Print the 4. Back. 4 plus 1, 5. This variable is going to be now 5. Lower than 7. Yes. Go down. Print the 5. Return. 5 plus 1. 6. Lower than 7. Yes. Go down. Print the 6. Return. 6 plus 1. 7. My variable I is going to have a 7 inside. It's going to go and check the condition. 7 is lower than 7. And for the first time, it's going to be false. And when this condition is false, just like with the while and the do while, now the program is going to jump and it's going to go to the line 8, the first line after the instruction 4. So just because that one is the closing of the main, the program is going to finish there, and that is the program that print the numbers 1 to 6. So 1, 2, the last number that is lower than 7. Did you notice what is happening? It's a loop, but now it's different. The first time in the left part, the next time, all the next times are returning to the right. So you have this idea of this one only one time was executed, and the condition and the increment of the variable run several times. Makes sense? If that one makes sense, for int a equal 5, semicolon, a lower, changing the operator, greater than 0, a equal a minus 2, just to change something. If I give you that program in your exam, and I ask you what is going to be printed on the screen, you know. Make sense? 5, 3, 1. Something that you will need to do a lot of times in programming, I mean, get the idea of what is happening is, well, this program is going to start here, and it's going to read the 4, and it's going to read this a equal 5. So the first time a is 5, it's going to check the condition. 5 is greater than 0, yes. It's going to go down. In this point, you're printing 5 for the first time. It's going to continue down. When you reach the closing curly bracket, now you're going to go up, but in this place. So 5 minus 2 now is 3. The 3 is going to be stored in A. Go here. 3 is greater than 0. Yes. Go down. Print the 3. So you have the 5, and now you have the 3. Return. 3 minus 2. 1. Condition. 1 greater than 0. Yes. Go down. Print the 1. So you have on the screen 5, 3, 1. Go back. 1 minus 2. Minus 1. A is minus 1. Minus 1 is greater than 0. False. In that point, when this is false, you are going to continue your program with the next instruction. So this program is going to print on the screen 531. Yeah. Yep. In this case, I put this minus, and the only reason because put the minus is because my condition is a greater than 0. But what if I made some updates here, and you know what? I want the a lower than them, and I want this a equal a plus 2. Can work. I agree. 579. So you get the idea. Basically, what I am trying to tell you is this flow that I draw with the red thing is like one time here and then this loop there and checking the condition. It's the same idea that we did yesterday with the while and the do while. Now, the only thing is the 3 elements are together, but we need to be careful that they are together, but we do not read them left to right, all of them. We read 2 and then the other 2, and only these 2 that are at the right part are the ones that continue being part of the loop. Good. Tricky question. 4. Char x equal a. Can I do that? A variable type char equal a quotation, single quotation. Good, right? I mean, one thing that I need you to know is the variables. We use integers a lot, but you can use any variable that you want. You need to be careful that your variable makes sense later with the condition, but any type of variable is okay. I am using a char now. Can I do something like my variable lower than or equal? X lower or equal C? You can do that because characters are numbers. Remember the Unicode symbol. So whatever number is in X is going to be compared with the numeric value of the character C, lowercase, and my condition is good. I put the semicolon. Be careful with the semicolons. The semicolons are part of the for loop. I mean, the semicolons are there because this is the variable. Now this is the condition. And after the semicolon, I can do the increment, right? So you can put everything in one line, that is fine. You can use multiple lines. Remember, the program don't care. So what about x equal x plus 1? Can I do a plus 1 with characters? And you remember, yes, you can. What is going to be the result of a plus 1? Because the initial value for the variable x is the letter a. What happens when you do the letter a plus 1? That is going to be the Unicode for the letter b. So a plus 1 is going to be b. B plus 1 is going to be c, and so on. So for loop, what I am going to print with this for loop? Just like before, I print numbers, right? Starting with this one and stopping with this one. You can imagine with letters, I am going to print the characters A, B, C, D, and so on, just because adding one here, adding one to a letter gives me the next letter in alphabetical order. So I am going to print all the letters, lowercase, obviously, A to C. A, B, C, D is going to stop with C. So you can do loops to work with numbers, but also you can do loops to work with alphabetical characters. Make sense? Hopefully, yes. Now, that one is easy. Key idea: initialization, increment, and condition. The same elements that you have with the while, now you have them with the for. The only thing, be careful. They are all together, but now you need to consider left or right. Use that thing. Usually, as I mentioned before, when you want to do something and you know that that something needs to happen a particular number of times, you know you want the numbers 1 to 10, you want the letters A to C, you know how many times that thing is going to happen, your first choice in programming is going to be the for loop. If you know the number, for loop usually is your first choice. For the while and the do while, usually the only thing that you know is if you want to do it 1 or 0 times and more. And that more is usually undefined. Undefined because maybe it depends of an input from the user. If your loop is controlled by something that you are going to ask the user, like, you know what is, do you want to continue, yes or no? And doing everything again depends of the user responding yes. Usually that one is a while or a do while, because the condition is depending of an input from the user, an answer from the user. If you know the number, like I want to print all the grades for all of you, I already know how many students I have. My selection is going to be a for loop, and for loop that is going to go from 1 to the number of students. If I know the number, for loop is my choice. If I do not know the number, like user, do you want to continue, yes or no? Do you want to play again, yes or no? Do you want to try again your password, yes or no? All those examples are whiles and do whiles. This part of the program that allows you to put your password wrong, try again, wrong, try again. That is usually a while or a do while. Makes sense? That is the only kind of quotation mark rule for the use of these three options. Most of the time, what you're going to check in your programs is for loops, usually. Now, something that you're going to notice, if you have a condition and that condition is too big, like think about the conditions that we reviewed during the exam, conditions that you use not only relational operators, but you're using and, or, not. If your condition is too long, sometimes you are going to choose to use while or do while, just because you can have your long condition in one place without the distraction of having also the variable and the increment. When you have a long condition, maybe that is something that point out to use while or do while. You do not want to be the for loop too long and having distractors at the beginning and at the end. Use ideas. Question in the chat, can we have this in the condition? Yes, you can. Anything that is a condition, any relational or logic operator can be used in the condition of the for, in the condition of the while, and in the condition of the do while. Anything can be used. Good. So, something that I need to review with you regarding the for, something that makes the for very, very special. This is the example that I explained to you before, and I want you to look at the elements that are inside of the parentheses. Look to them. All of them together, the initialization, the condition, and the increment. For loop, initialization, condition, and increment, all of them inside of the parentheses. What happened if I do this? Did you notice what I did? Look. Well, I removed the initialization from inside of the parentheses, but did you notice that I put the initialization outside of the for loop? The initialization is there, but now is before the for loop. Think about it. The result of this program and the result of this program is different or the same. How many times this initialization is going to happen? If you remember, according with this, only one time. And it was only one time because my program start here up, read the for, read the initialization, and then I am going to read the condition, right? But then the loop is going to keep happening here. So really, I only check the initialization one time. What about this one? I start here, go down, I make the initialization one time, continue, no initialization. Did you notice the semicolon? It's like, I didn't put anything between the parentheses and the semicolon. That means the initialization is empty, but I need the parentheses and I need the semicolon. And then I check the condition and the loop is going to be here. The two are the same. Two important things here. You can put your initialization inside of the for loop, or you can put your initialization outside of the for loop. They are the same. Obviously, the recommendation is, why are you going to put the initialization outside if you have a place for that inside? Obviously, my advice is use the space that you have inside. But my point is, if you do not want to do the initialization inside, the compiler, the language, is fine with that. The initialization can be empty in the loop. Again, the only reason because you have always you need to have that for a for. Because always the for loop know that, okay, this is the initialization, this is the condition, this is the increment. If you delete the semicolon, your for loop is going to complain because the compiler is going to tell you your for loop is incomplete. You only give me two things, but you need to give me three. And it's going to think that this one The first one, instead of being the condition, is the initialization. And you're going to have problems there. So when you tell the computer semicolon here, even though this space is empty, you are telling, hey, this thing here is the condition, not the initialization. This thing here is the second element that you're expecting, not the first one. That is the reason because we need the semicolon there. The semicolon is the one that divides the parentheses in three parts. Parentheses, semicolon, 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 closing parentheses, three parts. And the three parts in that order, initialization, condition, and increment. That is the order. Good? Now, step number one, you can put the initialization outside, and then you have empty the initialization in the parentheses. You can do it. Obviously, is do not do that. But it's a language. If you do that, makes sense, it's going to compile, it's going to run, it's going to do the same that the program before. But if I can do that with the initialization, can I do the same with the others? Like, what happened here? Yes. The increment. I do not want to put the increment in the parentheses. I like the increment below with the lines that I am running, just like we did before with the while and the do while. Can I do that? Yeah, you can do that. Because in the previous example, you run this when you return here. In this example, you are going to do your increment or decrement or whatever just before reading the closing curly brackets. You can do that. And if you notice, that one looks like the while state. If you change here for while, and obviously you delete the semicolons that you have after and before the parentheses, that one is a while. Do you remember that I mentioned that you can replace any for loop with a while, or any while with a for loop, or with a do while? I hope you notice what is the process to translate a for to while or a while to for, right? If I give you like, I have this int x equal 5, and then I have this while, and the condition for the while was x greater than 0, and then I have some instructions here, but in some point I make this x equal x minus 2, and then I close this. This is an example with the whiles, and this is an example that we reviewed yesterday. And if someone asks me, can you change that one for a for loop? The process is very straightforward. Is, you want to change this one for a for loop? Oh, this one needs to be for, semicolon here, done. Well, you want to move this line inside here? Okay. You want to move this line inside there? Good, done. Makes sense, hopefully. So, no initialization is outside. No increment is inside. The condition. For, parentheses, semicolon, semicolon, parentheses. You think that this one is going to compile? Yes. What is going to happen if you do not have a condition? This is an infinite loop. This loop is going to run forever, because if you do not give me a condition, I will assume that this is true. So easy. Do you remember that for the while, can I have a while and use empty. And the answer is no. If you have the while or the do while and the parentheses are empty, you're going to receive an error. When you want to do an infinite loop with while or with do while, at least you need to put something there. And if you want the loop to be infinite, you put true because that is the result, right? And this is going to be infinite. Or you can put 1 equal to 1, that always is going to be true. Or you can put something like 5 greater than 0, that is always going to be true. All of those options are going to make an infinite loop. With the for loop, for parentheses, semicolon, semicolon, parentheses, done. And I put here white spaces, but remember, you do not need the white spaces. I put the white spaces for you to be able to read this and show all the elements. But you can put this all together. The computer don't care about the spaces. You can even delete the white space here and the white space here. All the characters together. And that is an infinite loop with infinite for. So the conclusion here, initialization, condition, and increment. All of them are optional. Optional quotation marks, because if you do not put them, you have an infinite loop. And as we mentioned yesterday, sometimes you want an infinite loop. But so far for this class, for the kind of programs that I'm going to ask you to do, you do not need infinite loops. We are not going to do infinite loops in this class. Because again, infinite loops are related with hardware, network programming, web programming, mobile applications, things like maybe you're going to learn later, but not here. So far, for most of our programs, an infinite loop is going to be kind of something that you do not want to have, kind of, quotation marks, an error in your programs, just because you are not looking for that. But the language allows you to do this. The language is happy with something like this for the for loop. The only thing, do not forget about the semicolons, because again, 1, 2, 3, you need to tell the compiler, I do not have anything for any of the 3 elements. So you achieve that with the separations that are the semicolons. That's it. Clear so far? Hopefully, yes. Okay. Again, while 0 or more, the while 1 or more, and the for if you know how many times you want to do something. Yesterday, we put a while inside of a do while. Today, what do you think about this example? And this is the output. What is happening in this program? Following the process that I described before, hopefully you agree with me, my program starts in some point above, go down, read the for loop, read this initialization, right? So a recommendation for you is put a box in some place, remember that your box is I, and remember that it's 1. And a variable can have only 1 value. So that one is 1. If I replace that one, the one is going to be lost and a new value is going to arrive. So next I go left to right, check the condition. Condition, 1 lower or equal than 3. That is the condition that is true. 1 is lower or equal than 3. Because the condition is true, this one, go down. Go down where? To the next instruction. And the next instruction is this for loop, right? So just remember, it's going down, but that doesn't mean that it's going down to j equal 4. It's going down and it's going to read the next instruction. Before was a print, now it's another for loop. Another for loop, the same process. I read the for loop, and I am going to read this initialization. And that initialization is another variable that I need to remember, a variable j think about like a box, and that one have a value 4. Very, very common to initialize a variable with 1 or with 0, but it is not mandatory. You can put whatever you want. In the example that I showed you before, I used the letter A. Now I am using a different number, like 4. You can initialize something with 100, 1 million, whatever, depending on your problem. So J equal 4, good. Notice the line. At this point, I have not read I equal I plus 1. That part of the program, the computer haven't passed for that point. Anyway, continue, and I am checking the condition. J is greater or equal than 1. 4 greater or equal than 1. Yes, that is true. Go down, right? Go down, system out, println, and hopefully you remember the plus. What is going to happen with I plus string comma plus J? Hopefully you agree with me that the result there is going to be a string, just because one of the elements is a string. You remember this plus with the string is concatenation. I am not adding 4 plus 1 because I have this string in the middle. I mean, if you remove this string, then you can do 4 plus 1, the numbers. But because I have that string there, what I am doing is a concatenation thing. And hopefully you agree with me that is the concatenation of the number 1, a comma, and the number 4. And I am printing that. I am printing this part. Okay, I am done with the print. I use print 1, 4. I go down, and when I go down, I found the closing curly bracket. My question for you is the closing curly bracket for the red or the blue 4? And well, the closing curly bracket is blue color, so hopefully you agree with me that is the closing curly bracket for the 4 in blue, just because as with the parentheses, the inside one is going to open and close before the one that is outside. So this blue one here is going to make you to return. We're working with the 4, right? So it's going to return in the right part. It's going to return here. And what is going to happen is J equal J minus 1. That is the reason because it's important to have the boxes, because now I can just check J is 4. Minus 1, 3. And then the equal is going to store the 3 in J. So that basically means I want to store the 3 here. And just like that, the 4 do not exist anymore because I can only have one value inside of the variable. So J now is 3. I continue right to left. The condition is 3 is greater or equal to 1. It is still true. Go down. Again, you haven't read yet the I equal I plus 1. That line, I haven't done anything in that line. I am going down, and because I am going down, I am going to execute again the print. That one is going to print I, but this is still 1, the comma. And now the J is 3. It's going to return 3 minus 1 is going to be 2. The 2 is going to be stored in J. Now J is 2. 2 greater or equal than 1 is true. It's going to go down. Now I am going to print the string 1, 2. It's going to return 2 minus 1 is 1. And I am going to store the 1 in J. So now this J is going to be 1. 1 is greater or equal than 1. And that condition is true. Go down and print 1, 1, return 1 minus 1, now is 0. J is going to be equal to 0, right? 0, finally, the condition is 0 is greater or equal than 1, and that is false. And what is going to happen now that the condition is false? It's the first time that the condition in that loop is false. What I am going to do? Well, from this point, you are going to jump to the end of the for instruction, right? Remember, when the condition is false, you go to the next line after the for loop. The for loop is this thing here. So if you jump to the line after that one, from this point, you are going to jump and you are going to arrive here. And what is that? That is the closing curly bracket of another for loop. And what do you do when you reach the closing curly bracket of a for loop? You jump. This one is going to jump here. And for the first time, after you print all of this, for the first time you are doing something with the variable I. And you are doing I plus 1. And I plus 1, 2. And what do you want to do with the 2? Store in I. This variable is going to change, and now this variable is 2. Okay, done, 2. Right to left, because it's a 4. I check the condition. I is lower or equal than 3. 2 lower or equal than 3, that is true. Because that is true, what I am going to do is go down to the next instruction. The next instruction is again the for that I did before. I have a loop inside of a loop. What is going to happen? I am reading the for, and well, I am going to read left to right, and I am going to do this instruction again. What is going to happen? That J is going to have the value 4 again. And you can imagine that the loop is going to run just like before, but now the value for I is 2. This is going to be printed. And following the same process, next, those are going to be printed. Probably this is the first program that we are not reading at all as a line. Even with the if, almost a line. While and do while, there are loops, but always in the left. This one, hopefully you noticed with my lines and the 2 different colors, it's a little bit harder to read just because we are not reading full sentences. Hopefully makes sense. Something that I need to ask you. Familiarize yourself with this kind of example. Practice for loops. Obviously, you're going to do that during the lab, but at this point, as I asked you yesterday, at least copy paste this program, run this program in your computers, and be sure that you understand what is happening there. I tried to describe the flow, but maybe you need to review this again. I mean, go back to the video, put the program in your compilers, practice this. Probably so far, for loop is maybe the most challenging topic that we have reviewed. Usually in the exam, this is one topic that you want to review very, very carefully. You can expect several questions using this particular instruction because it's really important. It's the most important loop that you're going to find in programming. By the way, Java have this for loop, C++ have the for loop, C have the for loop, and several other languages that probably you're going to learn later have something equal or similar to this for loop. So please practice, review this example. One last thing before finishing. You notice that I have been using a lot, really kind of a lot, this variable equal the variable plus 1, or this variable equal the variable minus 1, whatever is the name of the variable. These two instructions, adding one or adding something to the variable, in particular one, and subtracting one from the variable, they are very, very common. And when something is very, very common, usually the people want to have an option short. You know, we do not want to write several characters when we are creating a document. So this instruction can be write in a program like bar plus plus semicolon. Every single time that you look up to a program and the program is a variable plus plus, the meaning is the variable equal to the same variable plus 1. And the opposite, every time that you look something like the variable minus minus, that one is something equivalent, the same, but the variable equal to the variable minus 1. So, for instance, I am going to show you programs like a minus minus. What I am telling you using a small number of characters is a equal a minus 1. That's it. That is the meaning of this minus minus and plus plus. And yes, they are used a lot with the loops because my program now can be something like this. No, not in Python, sorry. Makes sense. You're going to notice a lot of examples in the book and online with these operators, the plus plus and the minus minus. Now you know we use the short version of, in this case, I equal I plus 1, or the other one, j equal j minus 1. So I just use 1 plus and 1 minus. If you run this program, the output is exactly the same, basically because you are doing exactly the same as before. That is the for loop. So far, chapter 4 is what we have covered this week. While, do while, and now the for loop. They are in the chapter 4 of your book. In case you want to read the chapter, it will be very useful. At least my recommendation, check the exercises, review the source code, and the goal is for you, open the book, read source code with these instructions, and you should be able to understand what that source code is doing. Test yourselves. You should be able to read that source code with what we have reviewed so far. Good? So, any question so far? No? Good. See you tomorrow, guys. Thank you.